Thanks, Meghna, for the introduction. Did you guys understand what she told about right now? What I'm going to say? If yes, please raise your hands. Nothing to you. Okay, just it took me a couple of years to understand what I'm trying to say. So that's why. You are gonna do that, right? Cool. Yeah, that's me. So I am working as a security manager, operations manager in Ola. I like incident response, threat hunting, malware analysis, sci-fi movies, and traveling. I hike a lot. And then yeah, if you are interested in any of those, ping me in LinkedIn. We'll have a chat. Cool. Next. Okay. Before reading that, okay, let's look at me. So you guys know the history of cloud, right? It was initially your virtual machines that when could not be scaled properly, couldn't be available properly. That's when they thought about renting out your virtual machines to someone across the internet, and that's how cloud came into picture. Now cloud, around maybe 10 years back, cloud was the booming thing where people were like, it is better to choose cloud over infra. I mean, it is changing now, but fine. So right now what I'm trying to do in this whole talk is to do two things. First is to let you guys know what cloud services are there out in the wild, what can you use, what is the security measures that is there in that. Alright, so because obviously someone is trying to access something over the internet, a lot of others will also do the same thing. So that will be a avenue for attackers, right? Second thing is to enable you guys with how to understand when attack happens in a cloud environment, what are the situations when it happens, how to respond to that, and how do you stay protected. Now these terms are very widely used across multiple industries. When I say that, what I mean is that what are the frameworks you use to detect an attack, detect an anomaly, what are the frameworks you use to respond to it, matlab give it the right time, within the right priority, within the right tools and mechanisms, within the right perimeter. How do you respond to it, and also how do you prevent it from happening by applying the right protections. Cool. Hope I make sense. I know that some of you have come from that hackathon. If you're sleepy, I totally understand. You can go and sleep. Nothing bad wrong in that. Cool. So I'll start with a couple of services. First is compute service, basically like your CPU. Alright, so there will be EC2 in AWS or virtual machines in your Azure. These basically are your foundational machines that you can log into and or use to run some kind of loads. Can be any OS that you choose, mostly Linux is what they choose, right? And you can, how do we say, the security concern there is that you usually access this via internet, via SSH or RDP. If you guys have any doubt, question me. If you don't think I'm talking, don't worry about that. I like to be questioned. Question me, interrupt me. I am more and more happy for that only. Right? If I don't have a question, it means I have failed, basically. Right. Yeah. Can you read and let me know if you have any questions? Why should I be telling everything? I wrote it down. Any questions that you have? Because a couple of slides ahead, we will have scenarios where we will be actually simulating attacks here. So you guys would need this thing. So if you guys have any questions, let me know. Cool, no questions. Next slide. So once you have a compute, you also need storage to access your boot or access your storage files or anything, directories or anything. So basically we have storage services in cloud also. Your S3, your blob, all those things that are both object storage and block storage are there. Basically storing files and accessing in your machine. Alright, and then, okay. So how do I tell you this thing? Cool. End of the day, you are storing something in a publicly accessible storage thing, right? Let's say S3. So the main concern here is if you are making it public. All right. I'll come to all these things when I am going the scenario. Next, please. Next is database. Obviously, I guess all of you guys know the importance of database, how it actually works, and how it helps in modern applications. Right. So we have multiple managed database and relational databases in AWS and Azure and all those things. And there's a concept called shared responsibility model. Do you guys know about that? Shared responsibility model? Yes, no. Yes, no. I'll come to that, but if you guys don't know, I have a good analogy for that. And end of the day, we have to ensure that whatever we use should be proper and whatever they give us to be used should be proper. Next slide. And finally, you have something, machine is there, your storage is there, you have database, other items. It should be in a network perimeter because you are accessing via internet, right? So there should be a logical and a network perimeter here. So that is why you have networking services, including tunneling, peering, or VPC, all those things. VPC matlab virtual private cloud. That is what defines the network perimeter in a cloud system. Say you have a machine, you have a storage, right? So you have to define it within a perimeter of network, so it can talk to each other. Next. And this is secure tunneling and VPC peering are components that is used for communicating within PVC and inter VPC, so that we can communicate. Let's say you have two machines in two different network perimeters. They should both talk to each other in case, right? So we use systems like these to ensure that. Next one. Cool. Oh damn, I need to, can you minimize it because there are more things there? Is it possible? That's whole thing? I don't think so. Acha, cool, makes sense. So shared responsibility model basically means that you guys who all live in a rented house here or has a rented house, right? So when you have a rented house that you live in, you don't take care of the whole thing. There is a part of responsibility that lies in the owner also, right? But the owner doesn't get everything for you. You also have a responsibility to take care of the house. Similarly, not alike, but similarly, there's a model called shared responsibility where the cloud provider, say AWS or Azure or GCP or anything, right, would have to, assure in terms of security. That can be your platform security, that can be the communications within that. But then there is a set of checklists and if the user doesn't do, for example, making your storage public. If you intentionally make a storage public and someone else accesses that and thereby you get attacked, it is not my fault, it is not AWS's fault, it is your misconfiguration, thereby introducing the term called misconfiguration. So misconfiguration is a very widely, it is the main root cause or the major root cause of most cloud attacks, because the users not configure it properly, thereby exposing network or storage or compute or whatever it is, right? So you can see that compute, basically your infra as a service, that's IaaS, and storage, that's platform or infra as a service, and identity. So in example of AWS is EC2, right? So customer takes care of these items where the cloud service provider should take care of these items. Just read through it. If you have any questions, let me know. I know it's a very technical terms I had to do because the time was less, but let me know if you have any questions. It is very interesting to question each other because right now I am working in Ola and we are actually creating cloud right now as a provider. So we have to think from both angles, as a provider and as a customer. So it's very interesting to look at this concept in that way. So in identity, the last one, I'll tell you something. So when you log into your, let's say, Windows machine, you mostly would be logging in via AD, right? If you are in a DC network, or if you are logging into a Linux machine, you would be, you would be logging in as one user, right? So that is termed as identity in terms of cloud. So every system that you have in cloud, every system you have in cloud will have its own identity, and that identity would have its own permissions. Just like you do sudo su or sudo sudo for getting more permissions, right? Or just like having an administrator in Windows. Those are terms which you use because you know that has higher privileges. But behind the settings, you have to read about the permissions that are given to that. Similarly, in cloud also, each user and each component, be it your compute or storage, will have an identity and its roles, and the role will have defined parameters. For example, you might be a S3 bucket and you might be an EC2, right? If you are trying to say that there is a program that's connecting to your EC2 via VPC and there is an S3 that is collecting data from it, then you have to define parameters here and there to ensure that network is talking to each other and there is read, get or put or things like that to be enabled there. Is it going over the head? No? Good. So customers are responsible for configurations, patching, hardening, and providing the right, privileges, whereas the cloud service provider, that is CSP, is responsible for ensuring that the platform or the infra itself is secure. Cool. Next one. So basically you can see that there are multiple attacks that are caused due to misconfigurations. That is because of the user not configuring properly. Right. If you can read, next we'll go. We'll go next. I'll just give you some brief summary of what happened in the last 5 years. Next. So these numbers don't make sense unless you actually know the gravity of it. Okay. So exactly what I'm trying to tell here. Even if you say that cloud is a very complicated system, misconfiguration still amounts to a lot of attacks here. So is the cloud service providers level here, right? Next one. You can read this. If you have any questions, let me know. Basically, what it is saying is that you as a customer, when you configure your resources and configure your identity and give them the right privilege, there should be at least a basic hygiene of credential hardening to be done. That is also amounting to a lot of attacks. Next one. And yes, so anyone here has done any kind of certification regarding AWS or Azure? No one? Cool. Who all have worked with APIs, microservices? Cool. So if you have actually worked with APIs or have heard about APIs, when you have a program or some kind of function that has to be called via API, the whole thing is you run a call or you run something that will call the program via an API call. It can have its own action, maybe pause, maybe get, whatever it is, right? That will give a result to it. Cloud works entirely mostly on APIs. Every action will have an API. Even if your dashboard, you click on something, API is there. You double click, API is there. Everything has APIs. So that introduces a point where API attacks are also, or API abuses are also high here, right? And rate limiting. You guys know about rate limiting, right? Yes. Who doesn't know about rate limiting? You don't know. No, you don't know. Who doesn't know? I'll explain. It's fine. You don't know. Fine. Basically, it's like that door. How many people can enter parallelly? 3. Put 3. Max to max. They don't have breakfast. What can I say? Right. 3 max to max. And a set of 3 can enter at a rate of, let's say, 3 per second. Right. If it's 4, that won't hold. Right. If we are assume we are very strong, we are ultimately strong, that will break. Next scenario is that if 3 people or person get in at a rate of 1 second per second 3, how it will take less than like 1 or 2 minutes to fill the whole thing, alright, and the rest will be chalked there. So the only way is to ensure there is a limitation for people to enter, so that remains safe, and there is availability here also. So rate limiting also is the same concept, where in applications or in network, you should understand how much is the load the gateway can handle, how much is the load the program can handle, and then apply limitations on the gateway and the program so that it can trigger either bad response or trigger saying this is the limit of it until a time. That is basically rate limiting. So if you don't have rate limiting, what will happen is that unlimited number of responses will come and your program will choke, or the response will be bad, or there will be some kind of other issues. Yes, okay. The next thing is overly permissive IAM policies. Why I am going in details because the scenario that we're going to have will contain all of these things. So even if you don't understand the terminology here, if you don't get the concept, let me know. I'll give you the concept, because that is what is going to help you in the long run. Right. Cool. So overly permissive IAM policy basically means if you have a resource or a user with an identity, if you give permissions for more than what is required, like saying that you are giving every user in the cloud in your account admin privilege. If anyone's password gets leaked or anyone goes rogue, they will be able to do multiple unintended things. All right. So things like that has to be understood here. Next one. So I am coming into the NIST. NIST is a National Institute of Security. Something is a framework. Okay, that is widely used for understanding how do we apply security in a how do I say, in a whole process. So it begins with preparation, detection, analysis, containment, eradication, recovery, and post-incident activity. This talks about properly the incident response life cycle. You have to be, end of the day, what you are trying to do is that if some attack happens or if some flood happens, you have to respond to it. So to respond to it, you have to be properly prepared for that. And preparation can be like enable loggings, enable monitoring, enable the right kind of error codes, or enable the team to understand what is happening there. Right. And next one is detection and analysis. So detection basically means that, how do I tell you? You guys know about CloudTrail? Yeah, I don't think you know. Okay, do you guys know about Windows logs, Windows event IDs? The front row is an anomaly here. The back row is a reality here. Windows event IDs. Can someone tell me, please? Because I want to know what is actually the reality. If no, I'll explain. No worries. Should I explain? Cool. Basically, an event ID or basically means that let's say in a Windows system, okay. When you create a file, you're clicking somewhere, you're saying new file, something is there, na? That is an action. Similarly, you're logging into your machine. You're logging in from your console or network into your machine. That's an action or an event in that terminology. So for every possible event, Windows will have an event ID. So that when an event happens, it will register in its event registry, saying, hey, assume that logging in is event 4724. Assume, okay. So 4724 event ID happened, and then there will be more details about that, from which IP, what action happened, what timestamp. So this is it's called logging or enriching a log that will enable for future forensic purposes, where you are assuming, hey, someone logged into my account without my knowledge. How do you audit that? How do I know that? All right. So for that, systems create this kind of logging mechanism. In Linux, it comes under the directory var log. All right. Similarly, these two are mostly widely used or mostly widely known about this thing. In cloud, there will be trail logs, TRAIL logs. Trail logs basically mean all actions happened. See, you guys are EC2, you guys are S3, you guys are RDS, whatever it is. Every action happened to that or is used because of that will have an trail log. It will have timestamp, it will have what API call was done, what resource, what action was done, what is the result of that. Everything will be there in single log. So that when you actually detect something that is out of the baseline or out of the, which is an anomaly, you can have an alert for that. Alright, and that is where containment comes in picture. So alert is basically saying, hey, something is going wrong here. Alright, then you have to contain it, basically saying there's a fire there, and then you have to put on the fire. Fire is there, and I know because I am seeing that bright fire or I am feeling that heat of the fire. Alright, so knowing that itself is detection. I am analyzing, is it a big fire, is it a small fire, can I just stamp it, or is it spreading across? Then I have to contain it. So containment basically comes in the picture. Should I throw that bottle of water, right? Or should I use? Hey, where is this thing, man? There is no fire extinguisher. I got answer. Fine. So good luck. How do you run away from here if there is fire? I think that is over. Cool. So assume there is a fire extinguisher here, right? You use that to extinguish the fire. If it's a big fire, there is no other way. You have to run away. We have to run away. There is no other way. We can't stand here and get burnt, right? So containment basically means the immediate action to stop the impact of that. Then comes eradication. I'm saying, like, how would fire come here? Did she put the fire? Did she put the fire? Or I did put the fire? I don't know, right? So understanding who put the fire, or why fire came in the picture, or why was fire even allowed there. That is a rock surface. There's a bag there. Maybe bag got fire on fire, right? So understanding the eradication. So this comes into picture because left of hack is there, right of hack is there. Left of hack is that you should know where this happened from, why this happened. Right of hack is that you should know what is the impact of that. Now fire happened, you extinguished. Now what should I do? Is the fire burned? Is someone here burnt? I should be checked now. This is the integrity of the room is gone or not. So you should know these things. That's called right of hack. Then recovery. That is basically you should understand that attack happened. Fine. You took a machine was there, a malware came into picture. That malware is some kind of ransomware, and you deleted the system. Fine, but you are working in a business, and the business needs to have its operations. So you need to turn that machine on, or how do you repurpose the machine, or you give it new machine, right? It depends on that. So recovery, and then lessons learned. Basically, understanding the root cause, what actually failed, or what actually didn't happen here to get to this point of the attack. Am I clear here? Yes. Cool. Next. So, in AWS, these elements are being used for protection, detection, containment, and eradication. So for protection, we use IAM, config, KMS, and SCPs. Essentially, what you are seeing here is that we are giving them the right identity, the right privilege, the right security in terms of certificates, and then the right configurations. Once you have the right role with the right privilege, right, and the right how do I say perimeter defined, then we can at least limit if anything goes wrong. That is the sole purpose of protection here. All right. So enforce least privilege, set guardrails, right, mandate encryption, all those things. I saw there was a chart given outside having multiple what is that, puzzles there. I think one of the answers is encryption only. Maybe that. Next is detection, right? So in detection is that fine, protection is there. Assume that this whole floor is marbled. Okay. Ideally, fire shouldn't come. Ideally, because it's stone, it won't catch fire easily. Now, let's say that fire actually happened. How do you actually detect that? Then you need fire alarms or some kind of sensors to see something is going wrong. That is why you have detection here. In cloud or in specifically AWS, you have CloudTrail, GuardDuty, CloudWatch events. So CloudTrail is what I mentioned before about trail, the logs of things that is happening. GuardDuty is like the system that gives you alerts for any and every anomalies. Something, some S3 or a bucket is having high number of download actions, or some malware is happening there, or a malicious network communication is going outside. It can be a ransomware, it can be a malware, it can be a worm. All right. So GuardDuty takes care of these kind of things. And containment is basically IAM, revoke sessions, your EC2, VPC, security groups, WAF, all those things. So basically here what we say is that for containment, we look at what all capabilities does the provider give to reduce the impact. One can be remove all identities, remove all privileges, or one can be put a WAF. WAF is your web application firewall. That will take care of your layer 7 traffic. Layer 7 traffic you guys know, right? You don't know? Yeah. Layer 3 kya hai? Cool. No. And then you have eradication here. So eradication is basically to understand should we remove anything that was affected, be it credentials, be it resources or anything. All right. Yeah, that's it. Next one. Any questions here? Does it make sense to you guys? Cool. Yeah, I will start with my tabletop. before going to tabletop, I want to really understand. Did you guys understand this concept? If not, there is no point going here. I'll drive it my way. If you guys understood, we'll drive it your way. I will be dividing into groups, or at least segregating something, so that we can act as attackers or defenders in that sort. Or do you want to go with one section? There are 4 sections, and each section will have their own way of understanding what happened, what measures to take. Oh, okay. Tell me, what should we take? Should you go with step by step, like group by group? One step, all 4 groups will have same actions, or should I go with attacker or defender? You guys tell me.
People for attackers, defenders, I think we'll go in that way. You can raise your hands if you want.
It's fine. Attacker defender.
I assume there's no attacker defender means the other way is the way. It's not attacker defender, so this other way. Fine. Cool. We'll go forward with this thing. Where's the time right now? You have time, right? Can someone volunteer? Just someone, random thing. No, not for this. Hey, you don't volunteer. Oh,
Yeah, 3 minutes time left for the next talk. Next talk is at 10 as well.
Acha, is it 3 minutes? Damn. Then you go through this thing. Fine. So for this tabletop, what I was planning was that this is a scenario where this is the way the attacker came into the picture. Okay. So your incident response team is coming into picture for a company known as Chimera Corps. Okay. So an external actor or an attacker got access by getting a leaked key. You guys know about info stealers, malware that takes your passwords from your Google Chrome ka saved passwords. You guys don't know. It's a very good thing, because if you check some random Telegram channel or some random your dark web ka these things, you would see, I'm damn sure at least 75% of yours credentials would have been leaked. There's no question in that, because it's that bad in the case. All right. So in that similarity, so there was a leaked key, access key for the IAM called DevHost user. End of the day, there was a IAM user called DevHost user whose access key was leaked somehow, and the attacker got a hold of it. And the user is belonging to the DevOps group. DevOps matlab the team that handles the infra and spinning up all the required programs and infra, right? And the DevOps IAM user had a lot of permissions, like it had access to everything across the cloud, okay? And to launch EC2 instance, matlab launch machines, to assign permissions, and to give password also. Can you go to next one? Okay, so next one. Go to next one. Next one. Okay, so those 2 things doesn't make sense because we haven't time right now. But this is what, according assume we are all incident responders, where we are sitting in front of a screen where you get this alert like this. He is saying that there is a guard duty alert. Okay, matlab the intrusion detection system of your AWS is giving you an alert stating there is an event called credential access and IAM user anomalous behavior. So the guard duty found that there is an anomalous behavior happening for that user and gave the alert. Its job is done. It gives you the alert. Now it is our job to identify what was the anomaly, what was the action that is done, what is the impact of that, and what actions to be taken to contain and eradicate that. This is how an actual SOC works. So SOC stands for Security Operations Center. That's one of the primary defense teams in any company. So in SOC teams, if you are actually working in incident response team, the analyst will get this kind of alert. That's it, nothing else. And the analyst has to go through the platform to the events to understand what is this about, why is this an issue, and they clarify it as true positive or a false positive or benign if it is Okay, go next. So this is how we start with detection. Okay, we understand, we go to the CloudTrail. As I discussed with you, CloudTrail is the log cat trail, which will have all the event IDs or all the actions that are taken in the whole platform. Alright, and then we will see in the CloudTrail these kind of events. One can be initial compromise, whether there were any API calls to that user from external IP or from an anomalous IP out of the baseline. Right. Next can be that exploitation of privilege. Has that specific IAM user tried to access anything out of the ordinary or try to access anything beyond its current privilege. Right. So currently after that, the log that you guys would have seen confirms that the attacker has assigned to this new role called devadmin. Okay, this is basically that when you went through that in the tabletop, it would be like you see the log and then there is something new data in the log, and that you guys understand that there is a new role assigned to this thing, and that can have more permissions. Right. And then you are trying to understand what are the subsequent S3 API calls. Can you go next one? Can you go to the last one, before one? Just quick question. What do you guys think should be the containment here? Anything?
Revoke the key.
Revoke the key. Okay. Anything else?
Also track.
See, revoke the key is, it's like,
Root causes remove.
no. In other way, revoke the key is saying like you have a rat in a house, you burn the house. Okay, it is not bad. It is the last straw to go. But are there anything else that we can do to start doing small steps of containment?
So look at the trails and see whatever changes he did after getting the key. For example, he might have created a new key using the existing key, for example. So yeah, you'll have to look whatever changes the attacker did after getting access to the account.
Makes
And,
sense.
Try eliminating one by one, basically.
That's a good approach. Basically, what he's saying is that understand all the roles or privileges of that user, try to see what all the actions were, and then remove one by one privilege. Because this user is assigned to the DevOps team. They are a very crucial team in any company. They will be performing your platform spinning up, program spinning up, and most of them will be automated by Ansible or Terraform or something like that. Alright, so if some kind of user is that like this actually got leaked, it will be very hard to take the call of removing the user, because that might impact the whole pipeline of CI/CD itself. So we might have to understand perimeters and close one by one. Alright, so let's go next one. So the containment here is that we have to understand what is there. Can you go next one? That next one. So these are the basic containment steps we can do. Right. So one is to long-term deactivate the key. That can help here. Right. Then is to detach the high privilege this instance profile, so that it does not do, or the IAM does not do more damage. And next is to modify the security group. Matlab your ingress or egress traffic rules, IP rules. Give that ensure that there is a block on the IP from which this sign-in happened. Right. Next priority is to enforce MFA, because if MFA was there, this would have never happened. MFA stands for multi-factor authentication. Right. And then revoke all the active sessions. So assuming that there is breach, there is actually attacker got in, we need to revoke all sessions. If else that session will be alive and in their system right now. Then. Alright. And then take a snapshot of that specific whole VPC or the EC2, so that we can use it for further forensics. Alright, next one. So this is regarding eradication, the understanding the how to remove the root cause, whatever caused it, how do you remove it. Alright, so basically you talk about understanding the EC2 instances and removing that, and then what? Deleting any raw resources created by the attacker. It can be any programs, any automations, any storages, any computes that the attacker might have created, and then removing that. Right. Yeah, next one. And this is the part of protection. So guys, remember about the first one, identification, protection, containment, that. So for incident response, it mainly comes for two things: detection and incident response. Our main job is to understand if something is coming to our way, someone is screaming, hey, attack is there, what is the attack and how do you stop it? But then I'm going one step further and telling that, fine, okay, attack is coming and we are stopping that. But how do we stop the whole attack from coming in the first place? Right? That is where you have to have protection or better protection. So that is where you understand the root cause analysis and then apply the necessary patches there. So it can be you give it the right necessary privileges, make it less, broad in giving privileges, harden the systems, give proper MFA, give hardened keys, do not give password based authentication to machines, give key based authentication only, all these things, right? Next one. And then guardrail implementations, all those things are there. Next one. So this is the key takeaway from this thing. Just read about this now. I will take some time to tell all these things. Read this.
Is this the last one or is there like another one?
I think this is the last one. I must thank you guys.
I think we have reached this one.
Next one. Yeah, next one is thank you. That's it.
Okay.
Any questions? Next one, ma'am. Yeah, this is a cheat sheet regarding all the security tools and services in AWS that can be used for your purpose. Next one. That's me. So, if you guys have any questions, ask. If you guys have any issues or any points to discuss, you can ping me in LinkedIn. I will be talking back to you in 2 to 4 business days. So, yeah. No questions, right? Yeah.
So right now, like you mentioned about how a lot of cloud problems are mainly through the users, but right now, like especially this year, there have been a lot of problems in cloud with the providers aspect. Like just last month, we had 2 AWS outages and cloud outages.
So in security, there is a triad called CIA: confidentiality, integrity, availability. You guys know about that CIA triad? CIA triad? No? Yes, no? Cool. Basically, let's say I am party A, he's party B. Okay, I am sending a file from party A to party B. Confidentiality says that the party A to party B, no one else should see that. Integrity says that no, party A to party B, when you send a file, there shouldn't be change in the file. If there's a change, it should be known to the party B. Availability says that party A should be able to send, party B should be able to receive. Security comes in availability when an attack causes drop in security, but outages are not security issues per se, or at least the RCA that which AWS or Azure has posted mostly come across as either availability issues from the outage aspect of some kind of DNS issues or IAM issues. So yeah, but you are right, there are attack scenarios where provider services itself has been attacked. One example is that the Lambda service was actually exploitable via some kind of command injection. So we can read about that. No questions, right? Cool. Thanks guys. Have a good day.
Thank you to Mr. Ananthakrishnan for an insightful session on cloud security. The discussion on networking, secure tunneling, and the shared responsibility model offered clear insights into how cloud attacks occur and how we can stay protected. Though time was short, the session was highly interactive and left us wanting to dive even deeper into the world of cloud security. As a token of appreciation, I would now like to invite Mr. Raghavendra Sudha